Good evening, everyone. So today we'll be starting with mole concept. So we are going to cover some basics about it. Now, what is mole? The mole term was given by a scientist known as Avogadro. Now, it is a method to represent various chemical entities. Like if we are purchasing anything from market, like a bunch of bananas, then we represent it in the form of, say, uh, a dozen. Give me a dozen bananas, etc. So in chemical reactions, if you have to represent something or represent some quantity, then we have to have a unit, uniform unit, which can be used everywhere, and that we call it as mole. And this mole quantity is a constant quantity which was given by Avogadro as quantity is 6.023 into 10 per 23 particles. It was a fixed term which was given by Avogadro. Uh, we know that we denote the atomic mass by a fixed term is known as U, or also known as EMU. There is slight confusion among people for U and grams that are clear today. We know that the atomic mass of oxygen is 16, okay, and we denote it by U. U is nothing but it's consisting of one atom only, okay. 16U is the atomic weight of one atom. While if we denote it in grams, it will be called as gram atomic mass, and it will consist of not one atom now, this time it will consist of 1 mole of oxygen atoms. Now this quantity refers to both atoms as well as molecules and ions, everything. It's not specific for an atom only or ion only. If we are referring to as 2 grams of hydrogen gas molecule, that will consist of 1 mole of hydrogen molecules. Now that will consist of 2 moles of hydrogen atoms. If we are referring to 32 grams of oxygen, that will consist of 1 mole of oxygen gas, and it will be consisting of 2 mole of oxygen atoms. So now what we can conclude from this, that the gram atomic mass or the gram molecular mass will be equal to 1 mole of the particles. Either it be molecule, either it be atom. There is one more relationship which is very important for solving the numericals, and that is that the 1 mole of gas is equal to, or we can say is equivalent to 22.4 liters of volume of the gas. So if we are referring to 2 grams of hydrogen, then what it will be? It will refer to 1 mole of hydrogen, that we have understood. It will also refer to 22.4 liters of hydrogen gas. Simply if we say, if we represent 8 grams of hydrogen, 8 grams of hydrogen means, if we calculate it, will become 4 moles of hydrogen. 4 moles of hydrogen, and we know that the volume of 1 mole is 22.4 liters, so here it is consists of 4 moles, so the volume will be 4 into 22.4 liters. So it will be about 89. First numerical we are doing is, we have to calculate the number of moles in 5 grams of sodium, or 5.75 grams of sodium. Number of moles in 5.75 grams of sodium. So we know that the atomic mass of sodium is 23. If we represent in the grams or gram atomic mass, that it will be 23 grams. So 23 grams, we can say 23 grams of sodium is consisting of 1 mole of sodium. So by unitary method, simply we can do it that 5.75 grams will consist of how many moles? We can say it 1 upon 23 into 5.75, which will give us about roughly 0.25 moles. So we can do this numerical simply by unitary method basis. We will do some more examples. Now what is the mass in grams of a single atom of chlorine? Now we know that the mass of 6 into 10 to the 23 atoms of chlorine is 35.5. So the mass of one atom of chlorine will be 35.5 divided by 6 into 10 to the 23. So the answer will be 5.9 into 10 to the minus 23 grams. This is the weight of one atom of chlorine. Next question is, if the mass of a single atom of an element M is 3.15 into 10 to the minus 23 grams, if the mass of a single atom is given, so what is the atomic mass? So usually we can see here that the mass of element M is of one atom and they are giving us 3.15 10 to the minus 23 grams. If we have to calculate the atomic mass, we can easily calculate by saying that how much will the 6 into 10 to the 23 particles will weigh. That will give us the atomic weight of M. One atom has mass 3.15 into 10 to the power minus 23. Okay. So 6 into 10 to the 23 atoms will be having mass equal to atomic mass. The simple calculation, it will give about 18 grams. So next question we will be doing the easy question saying that 6.023 into 10 to the power 23 molecules of oxygen is equal to how many moles? So number of moles we can calculate by saying number of moles is equal to number of molecules of oxygen upon Avogadro's number of molecules. That will give N by Na. That will give 6.02 into 10 to the 23 upon the same Na quantity 6.02 into 10 to the 23. That will give 1. Means that's consisting of 1 mole of the atom, the molecules of oxygen. Now we will do one question on the basis of mass volume relationship, which is saying that calculate the volume of 20 grams of hydrogen. Two grams of hydrogen is consisting of, there's a molecular mass of hydrogen is consisting of 22.4 liters. So 8 grams, how much the quantity we can calculate directly? 22.4 upon 2 into 8, that will give about 22.4 into 4, that's about 89. So 89 liters of hydrogen will be present in 8 grams of hydrogen.